And this magnification is also given by minus V by U. What is V? V is the image distance.
Yeah.
U is the
Object.
object distance. So keep in mind this formula of magnification, and this formula will be used in solving the numerical and in
Yeah.
solving some theoretical problem also. Okay. Height above the principal axis is positive and height below the principal axis is negative. So height above the principal axis is positive, height below the principal axis is negative. So if the height is like this, it will be considered as positive. If the height is like this, and it will be considered as negative.
Yeah.
Below the principal axis, negative.
Negative.
Above the principal axis, positive.
Yes.
So this is the magnification. So remember this thing. What is magnification? Magnification is height of the image divided by the height of the object, and magnification is also equal to minus V by U. So we can also prove why this height of image is equal to height of image divided by height of object is equal to this. By the similarity of triangle, we can prove this, but there is no requirement, so that is why I am not proving it. But with the help of the incident ray and similarity of the triangle, we can prove this. Now we will solve the numerical problem. So what they are asking? They are asking find the position. Position means you can say the location. Size. Size means you can say height
Yeah.
or length. Height or length you can. And the nature. Nature means whether the image is real, inverted, or virtual or erect. This is the meaning of the nature.
Okay.
Of an image formed by a concave mirror of focal length 10 centimeter, when an object of 2 centimeter long is kept in front of it at a distance of first 15 centimeter and B is 5 centimeter. First we are placing, first the object is at a distance of 15 centimeter, and after you are placing the object at a distance of 5 centimeter, and I have told you we will measure the distance always from the pole.
Yeah.
So pole will be here as like the origin. Like in
Okay.
coordinate geometry, we have origin. So as all the distances there we take from the origin. So you can just say, imagine, you can just relate this thing with that. So we will solve this question. It is given that a concave mirror is there. So concave mirror is there. I will draw the diagram, okay, to show you how the image and object are located and where the image is forming and all that things. So always just try to draw. I am not saying always draw diagram. Always try to draw the diagram to solve the question through diagram.
Okay.
So all the things will be just visualized. So this is the concave mirror we know. And if
Yeah.
this is a concave mirror, so we should draw the principal axis. So this is the principal axis, suppose. And focal length is given. Uh, what is the value of the focal length? So focal length of 10 centimeters. So of this mirror, the focal length is of 10 centimeter.
Yeah.
Small f is equal to 10 centimeter. So we will take minus 10 centimeter because I have told you for the concave mirror, the focal length we take negative. Okay.
Okay.
Height of the object is given and the object is placed at 15 centimeter. So for example,
15
suppose
centimeter
this
from the
is
pole.
yeah 15 centimeter from the pole.
Okay.
If nothing is mentioned now, always you will assume the object distance from the pole. And
Okay,
what
sir.
is the height of this object? 2 centimeter.
2. Yeah.
And this distance of the object from the pole is 15 centimeter.
Yeah.
And this is the pole.
Yes.
So we will take the object distance negative or positive. You can see this is the object. This is
Yeah.
the object. And from this object, the rays will be like this.
Yes.
This is the direction of the
So
incident rays.
positive. Positive.
Yeah. So if you are going in this direction, means in this direction, you will take positive.
Yeah.
Now you have to measure the object distance. So for measuring the object distance, you will measure from the pole. And
Yes.
for measuring the distance, you will go in this direction. So means
Yes.
this object
Negative.
distance also will be negative.
Yeah. Negative.
This will be negative, not the positive. Why? Because this is the
Because
direction of the incident ray,
yeah.
and in this direction you are measuring the distance. So that is
Yeah.
why object distance U is the object distance, and U is known as the small u is the object distance, and you will take it as a minus 15 centimeter.
Okay.
First thing is to find the position of the image. What is the meaning of the position? Means the value of V, small v. V is known as the image distance or the position of the image.
Mhm.
Okay. We know the mirror formula, 1 upon f, 1 upon v plus 1 upon u. 1
Yes.
upon f is equal to 1 upon v
So
plus 1 upon u. We have all the values. With sign we will put all the values, but for the unknown we will not take any sign. Here
okay.
v is the unknown, we will not take
Yeah.
any sign. So 1 upon f. So what is the focal length? Means 1 upon minus 10.
Yeah. Minus 10.
1 upon v means v we have to find, plus 1 upon u. U is minus
Minus
15.
15.
So from here we can solve it. It will become 1 by v is equal
Yeah.
to this 15 will give go that side. So it will become
Yeah.
1
Positive
upon
15.
15 minus 1 upon 10.
Yes.
So here you can take LCM,
Yes.
and 15 to the 13 and 10 3s. So it will become minus 1 by 30. So 1 upon v is equal to minus 1 by 30. So the value of v will be minus of 30 centimeter. So the position of the image is minus 30 centimeter, and this minus sign is showing that the image is formed in front of the mirror. Image is formed some here, means in front of the mirror, because here in front of the mirrored the distance you will take a negative distance, because the object is also in front of the mirror. So image will be somewhere here and at a distance of 30 centimeter. So in this direction you will measure the distance, no?
Yeah.
So this will be the image, and this distance will be 30 centimeter. Negative sign here, na negative sign shows that image formed in front of mirror. Why I am saying the image is formed in front of the mirror? Because the object is placed in front of the mirror, and if you are going in this direction, this is the direction of the incident light. So if image will form in front of the mirror, so for measuring that distance you have to move from pole to this direction, and that direction will be the negative direction. So this 30 centimeter will be minus 30 in terms of the sign convention, and this is the image.
Yeah.
I don't know whether the image is above the principal axis or below the principal axis this time. This time I do not know. That will be given by the magnification.
Okay.
That will be given by the magnification. So now we will see what is the magnification here. So for the magnification, we can use this formula, height of image divided by height of object,
Mm.
or there is one more formula, minus v by u.
Yes.
So we have the height of the object. We do not have height of the image, but
Yeah.
we have this and this. So we will use this.
Okay.
So for finding the magnification, we will use minus v by u. So minus, what is v?
Minus
V is minus 30. With
Yes.
sign, we will put the value in this formula. So
Yes.
it is minus 30.
So it will become 30.
U is the minus 15. U is minus 15 here. So we will put here minus 15. So magnification will come out to be minus 2.
Yeah.
Magnification will come out to be minus 2. Now, sign of the magnification is negative. Sign of the magnification is negative. And in the
So
starting, I
below
have told you, if the magnification is negative, then the image is real and inverted.
it's inverted.
Image is real and inverted. Okay.
Yeah.
Real
Real
and
and inverted.
inverted. If the magnification was come out to be positive, then we say the image is
Real and
virtual and erect. Virtual. And now talking about the magnitude of the magnification, means mod of magnification is greater than 1. Na? You will
Yeah.
take the mod of magnification, that is 2. 2 is greater than 1. What it indicates? It indicates that the size of the object is greater than the size of the image. Okay. So image is larger than object. Okay. And after that, they are saying calculate the we have what we have calculated. We have calculated the position. We have calculated the nature. Nature means the image, whether the image is real, virtual. Now we will calculate the size. Okay. So this magnification value minus 2 is giving the idea of the size. Means the image is larger than the object. But exactly to calculate the size of the image, again we will apply the magnification. So we have the magnification, height of image divided by height of object. So now what is the value of the magnification? We have minus 2.
Yeah.
Height of the image we want to find. Height of the image means image size. And height of the object, what is the height of the object? 2 centimeter. And you
2
will take this
centimeter.
positive. Why? Because this is above the principal axis.
Yes.
So you will take it as positive, plus 2. So height of the image will be minus 4 centimeter. Now height of the image is minus 4 centimeter.
It's below.
And here is the minus sign. What is the
Yeah.
minus sign indicates? The image is
It's
formed
below
below
the
principal
principal.
axis.
Yeah.
So image will be like this. Here the location of the image is already we have calculated, but now we can just say with the surety that the image will be inverted
Yeah.
below the principal axis like this. And size of the image is greater. Okay. So
Yeah.
here I have not shown the size of the image will be 4 centimeter. Okay. So this is the size of the image. Height of the image is basically the size of the image. So position of the image is 30 centimeter in front of the mirror.
Yeah.
Okay. And size of the image is 4 centimeter below the principal axis, or you can just write h is equal to minus 4 centimeter also. Your answer will be considered as correct.
Okay.
And if you will write v is equal to minus 30 centimeter, then also your answer will be right, until and unless the examiner is asking which side the image will be.
Okay.
And nature is real and inverted, so you can calculate with the help of the magnification. Image is real and inverted because the magnification value is negative. So okay, so you can take the screenshots now.
Done.
Done.
Yes. Done.
Done. Okay.
Done.
Done. Okay. So second part, in the second part, you have to place the object at a distance of 5 centimeter. You can see here, and you can just try out this question by yourself.
Okay.
Okay, 5 centimeter. So remember, you have what you have to do now. In that case, you will place the object at a distance of 5 centimeter. Accordingly, your image distance will be changed, and accordingly, your magnification change. Accordingly, the characteristics change or not change. You can see with the help of. Okay, so this is all about the reflection of the light. Now we will discuss the refraction. So what is the refraction? Refraction is basically whenever the light is traveling from one medium to another. What is the meaning of the one medium to another? Suppose the light is traveling from air to water.
Yeah.
So the bending of the light takes place, and this phenomena is known as the refraction of light. Okay. So when a light traveling from one medium to another medium, that medium can be air, medium can be glass, medium can be oil, medium can be any other medium. So whenever the light travels from one medium to another medium, the bending of the light is taking place, and that is known as the refraction of light. Okay. There are two types of medium: optically rarer medium and optically denser medium. Optically rarer medium and optically denser medium.
Yeah.
So the medium in which the speed of light is less, relatively less. So you can say that medium is optically denser medium. Like denser medium, for example, water is a denser medium as compared to air.
Yeah.
So when you will calculate the speed of the light in water, that will be less than that of air. So it means that the water is a denser medium. For example, what is rarer medium? Now air as compared to water is rarer medium. So in air, the speed of light is greater as compared to water.
Yeah.
So now how we will decide which medium will be greater, which medium will be optically denser and optically rarer. So there is a term defined, uh, refractive index. So with the
Yeah.
help of the refractive index, we will decide the medium will be rare or medium will be denser. If I am giving you that two medium, one having the greater refractive index, another having the less refractive index. So the medium having the greater refractive index will be considered as rarer, denser medium. So
Okay.
all these things I will discuss. Hmm. Hmm. Okay. So you can see here, what is the refractive index? What is the refraction of light? So this is one medium and this is another medium. Suppose this one medium is air. Suppose this medium is air.
Yeah.
Suppose it can be any other medium also. And suppose this is the water. So this is the incident ray, and this is the interface. Interface means the separating two medium. So interface, this is the interface which is separating two medium. This is the incident ray, and this incident ray is just crossing the medium here. So now you can see the bending of the light taking place. You can see. Is it or not? This is there is a bending now.
Yeah.
This light ray should go straight like this. But due to the change in the medium, the light ray is bending towards the normal, and this is the normal.
Yeah. Okay.
So this phenomena is known as the refraction. Now I have told you optically denser medium in which the light travels slower, relatively slower. Optically rarer medium in which the light travels faster. Note, and there is a term optical density. So basically, the optical density is just telling us how the medium is denser or rarer. And basically, that is just given by the refractive index. So mostly we will discuss refractive index, not the optical density. So refractive index is a measure of the optical density. Like we know the mass density we have. So mass density means how much mass is contained per unit volume. Like that, optical density is representing how the medium is rarer or how the medium is denser.
Yeah.
Totally, this will be given by the refractive index, because the refractive index is a measure of optical density. Now we will see what is the refractive index. So refractive index of a medium is equal to the speed of light in a vacuum or air divided by the speed of light in that medium. Divided by the speed of light in that medium. For example, we can take one example. Suppose it, and refractive index is represented by mu. Refractive index is represented by mu. So, for example, suppose if I am saying refractive index of glass,
Yeah.
G means glass, then you will say the speed of light, refractive index of the glass is equal to the speed of light in glass, speed of light in air or
Yes.
vacuum divided by the speed of light in glass.
Okay.
And speed of light in air or vacuum is given by 3 into 10 to the power 8 meter per second.
Yeah.
C is the speed of light, V is the speed of light in medium, mu is the refractive index of the medium. Remember, there will be no unit of refractive index. Why? Because here also the speed, here also the speed. So there will be, this refractive index is unitless.
Okay.
Another point about the refractive index, always remember the speed of light is greatest in air or vacuum.
Yeah.
This value of speed of light cannot travel less than this speed,
Okay.
no matter which medium is there. Okay.
Okay.
So this is the maximum speed of light, means the C value will always be greater than the V value.
Yeah.
So numerator will be always greater than the denominator. So you can say the refractive index will always greater than 1. And when the refractive index is increasing, means there are two medium and one medium with the more refractive index, means it is relatively denser medium.
Yeah.
So if the refractive index is increasing, means you are saying that the medium becomes denser, and if the medium becomes denser, the speed of the light will be decreased or less. So you can write speed of light decreases when refractive index increases. So you can say, and if you want to calculate the refractive index of the air, so how you will calculate? So you have speed of light in air here in numerator. In denominator also you will put speed of light in air. So c by c will be cancelled out, and you
Yeah.
will get refractive index of the air is equal to 1.
Oh.
So what is the meaning of the statement here written? For example, uh, refractive index of diamond is 4. Diamond is 4. So see, what is the meaning of this statement? Refractive index of diamond is equal to 2.4. And what is the refractive index? Speed of light in air divided by speed of light in diamond.
Yeah.
Here is the diamond, so you will take speed of light in diamond. So you can just calculate this value. Speed of light in diamond is equal to speed of light in air divided by 2.4. So this 2.4 refractive index of diamond is just signify that the speed of light in diamond is 1 upon 2.4, 1 upon 2.4 times of speed of light in air. Means speed of light in diamond is less than the speed of light in air.
Mm.
Okay, Vd is the speed of light in diamond. And we know that light is an electromagnetic wave. Light is a wave.
Yeah.
So for wave, there is a relation between the speed, frequency, and wavelength. So this is that relation. Speed of the wave is equal to frequency times of lambda. Frequency of the wave and wavelength. So for light also you can apply this equation, because light is also the wave. V is equal to f lambda. Okay, so now we will see. You can see here the speed of light is changing. The speed of light is changing in different medium.
Yeah.
So you can say that if the speed of light is changing in different medium, then frequency can also change, or lambda can also change, because speed is depending upon frequency and lambda.
Yeah.
Okay,
Yes.
but what happens now? What happens during the refraction of the light? Frequency remains same. During the refraction of the light, the frequency remains same, but the wavelength of the light changes. Okay, here is the refraction taking place. This is the medium 1 and this is the medium 2. Okay, medium 1 and medium 2 is there. So this is the medium 1 and this is the medium 2. So this is the medium 2. So in this medium, the refractive index of this medium is mu1, and speed of light in this medium is v1, and wavelength of the light is lambda1. Wavelength of the light is lambda1. And talking about the frequency, so frequency here will be f, and here also the frequency is f. Frequency is not changing during the refraction. I will tell you why. So okay, this is the interface. So here, as it is as light is bending towards the normal. Have I told you the bending of light? Okay, after this we
No.
will discuss. Huh. This is the incident ray, and this is the refracted ray. So refracted ray, this is the refracted ray. So during the refraction, velocity of light, speed of light will change, wavelength of the light will change, but the frequency will never change. So basically, frequency is depending upon the source from where the light is coming. Until and unless you are not changing the source of the light, the frequency of the light will never change. Okay.
Mm.
So here the light source is same. Source of the light is coming, suppose from the sun or suppose from any other object. So object is same,
Yeah.
source is same. That is why the frequency is same. So mu is representing refractive index, lambda is representing wavelength, speed of light. So during refraction, frequency of light remains same, and this is very important to remember. Otherwise, okay. And why the frequency is remains same? Why? Because The source frequency depends upon the source. Okay, frequency is
Okay.
depending upon the source. So we can just add here why the frequency is not changing. Frequency is not changing because of source is not changing. Frequency of light during refraction does not changes because frequency depending upon source. Frequency depends upon source upon source. Source means from where the light is coming. Now there are certain relation here. You can see, we know that if the refractive index will increase, the speed of light will decrease, or you can say if the speed of light will decrease, or then the refractive index will increase. So you can say refractive index is inversely proportional to the speed of light in
Yeah.
different medium. So there is a relation that is refractive index for this medium. This relation will be followed. Mu2 by mu1 is equal to v1 by v2. What is v1? Speed of light in medium 1.
Yeah.
Okay, and this relation you can derive. V1 by v2 can be written as f into lambda 1. Why f into lambda 1? Because v is equal to frequency into lambda. Speed of light in medium, speed of wave in medium, it is better to write in medium here. In medium. Frequency of wave in that medium and wavelength. So speed of light in medium is equal to frequency in that medium multiplied by wavelength in that medium. So here speed of light in medium 1 divided by speed of light in medium 2 equal to frequency in that medium
Yeah.
f, and lambda 1 is the wavelength in that medium divided by frequency. Why frequency is same? Because medium changes but the frequency of the light does not changes. So that is why v1 by v2 can be written as lambda 1 by lambda 2. So this relation is very important. Okay, so now you can take the screenshots.
Done.
Done. Okay.
Done.
Here is one more thing I want to tell you. One more thing, just wait. Relative refractive index. If it is written that uh, refractive index of medium 2 divided by the refractive index of medium 1. So this can be written as refractive index of medium 2 with respect to medium 1. So what is the meaning of this? This means that refractive index of medium 2 with respect to medium 1. Okay, so this is also very important point. Relative refractive index. Now you can take this screenshot.
Done.
Done. Okay.
Done. Done. That's
Okay. Okay, so now we will discuss how the bending of light will take place. Means how the bending of light will take place when the light can move from rarer medium to denser medium to rarer medium. Light can, for example, light can travel from air to water or from water to air.
yeah.
So air is a rarer and water is a denser. So we will see how there is a bending of light take place. Okay, so this is the interface between the two medium, and suppose this is the medium number 1. This is the interface. What is the meaning of interface? Interface separating the two medium, and this is the medium 2. So medium 1 and medium 2, and this is the incident ray. This is the incident ray. This is the incident ray, and this is what? This is normal.
Yes.
Normal makes the 90-degree angle with the plane surface, with the surface. Here is the plane surface, that is why it is making an angle of 90 degree. Okay. So this medium is suppose a rarer medium, and this have the refractive index mu1, and suppose this is the medium, denser medium, this have the refractive index mu2. So can you tell me mu1 will be greater or mu2 will be greater?
Mu1, right?
No. Denser medium have larger refractive
Yeah,
index, so
so
mu2 will be greater than
yeah.
mu1. So whenever the light is traveling from denser medium to rarer medium, whenever the light is traveling from rarer medium to denser medium, it will bend towards the normal. It will bend towards the normal. Okay, so bending towards the normal. So you can write light bends towards normal when coming from rarer to denser. Rarer to denser medium. Okay, if I am saying ray of light is going from denser to rarer, this medium is denser medium, and this medium is rarer medium.
Yes.
If you just want to imagine, to denser, you can take the example water. For example, water. So light is traveling this time from water to air. Water to rarer is air.
Yeah.
So this is the incident ray and this is the normal. So this time the light will bend away from the normal. Light will bend away from the normal, like this. Bends away from normal, denser to rarer. What this is the interface. Okay, if this is a case, suppose this is one medium, this is another medium, this is the interface, and if light is traveling like this normally to the surface, okay, light is traveling normally to the surface. So in this case now what happens, light will suffer no bending, there will be no bending of light will take place. Here the medium is different, here the medium are different, this is different medium, here is different medium, but then also the light ray is not suffering, light ray is not bending.
Yeah.
Okay? This case you should remember. This is known as the normal incidence. Normal
Incidence.
incidence. Why this is normal incidence? Because this is also a normal. If a
Yeah.
light is just moving along the normal, then there will be no bending. You can see the refractive index is different. Now, if for example it is given that light is passed straight like this, light suffers no bending.
Yeah.
So it can only be possible. It can only be possible, and that too with the oblique incidence. Means this is not the normal incident. The normal incident will be like this. So if this is the condition, then here you will say mu refractive index of medium 1 is equal to refractive index of medium 2.
Yes.
Okay. Refractive
Okay.
index of medium 1 is equal to refractive index of medium 2. So there is a relation between the speed of light and uh, I think I have already told you this thing. Relation between the speed of light, wavelength of the light, and here I have told you now. Here. This relation na speed of light and all that.
Yes.
So no need of this. So you can just take the screenshot. I am zooming it out. Just wait.
No. That's is done.
Done.
Yeah.
Okay. Now we will solve some questions. Hmm. Hmm. Uh, VW means the speed of light in water, and VG means speed of light in glass. So uh, W here is representing water, and G here is representing glass. Okay. So some information is given to us. Speed of light in water is equal to this. Speed of light in glass is equal to this.
Yeah.
Calculate refractive index of water. Calculate refractive index of glass. Calculate refractive index of glass with respect to water. Refractive index of glass with respect to water. Okay. First question. First answer. Refractive index of water is equal to speed of light in air divided by the speed of light in water. Is it or not?
Yeah.
I have told you the formula for the refractive index. Refractive index of any medium is equal to speed of light in air divided by speed of light in that medium.
Yeah.
Now, what is the speed of light in air? This value you should know. 3 into 10 to the power 8
Yes.
meter per second. Speed of light in water, this is the value 2.25. 2.25 into 10 to the power 8. 2.25, and this 10 to the power 8 will be cancelled out with 10 to the power 8. So what you have? You have, when you will remove this point here, you will have 300. Here you will have 225. Now you can just cancel out with 5. 5 6 are 30, and here is 1 0, and 5 4 are 20, and 5 5 are 25. Again, divided by 5. So when you will divide it by 5, then it will become 5 1s are 5, and 5 2s are 10, and is 5 9s are. Now divide it by 3.
Yes.
12 by 9. So 3 4s are 12, and 3 3s are 9. So it will become 4 by 3. So what is the refractive index of water? 4 by 3. And when you will calculate this, so it will become, when you will divide it, so 3 1s are 3, and here will be 10. So 3 3s are 9. So it will become 1.3333. Okay. It will become 1.33. So there will be no unit of refractive index. Okay. Second, they are asking is the refractive index of water, refractive index of glass. So refractive index of glass is equal to speed of light in air divided by speed of light in glass. Speed of light in air is 3 into this. Speed of light in glass given 2 into 10 to the power 8. 2 into 10 to the power 8. So 10 to the power 8 will be cancel out. We will have 3 by 2. 3 by 2, or you can say 1.5. Third, they are asking mu G written here and W written here. So what does it mean? So it means the refractive index of glass with respect to water. Okay. So if it is written that, I have told you that if it is written that 1 here is 2, here is 1, refractive index of medium second with respect to refractive index of medium 1. So you can write refractive index of medium 2 divided by the refractive index of medium 1. Keep in mind this thing. Now we can apply this here. We want to find this value, refractive index of glass with respect to water. So it can be written as refractive index of glass with respect to water can be written as refractive index of glass divided by refractive index of water. What is the value of the refractive index of the glass? 1.5. What is the value of refractive index of water? 1.33. Okay. 1.33. Okay. So if we will solve this in this way, refractive index of glass is 3 by 2. Okay. Refractive index of glass, I can write 3 by 2 also. So it will be 3 by 2. Now what is the refractive index of water? 4 by 3. So it will be 4 by 3. So what you will get? You will get 3 by 2 multiplied by 3 by 4. Finally, you will get 9 by 8. So what will be the refractive index of glass with respect to water? 9 by 8. So when you will cancel it out, so it will become 8 1s are 8, 1 point something. And after 1.2, okay, we can divide it. 9, 8 1s are 8, 1.0, 8 1s are 8. Again, it will have 2. So it will have 20, 8 to the 16. So it will become 40, 1.125. 1.125 will be your answer. Now, second question. First question is based on the refractive index. Second question is based on the wavelength and refractive index. Relation between the wavelength and the refractive index. Okay, so it is given that A is representing here air, and D is representing here diamond. And lambda means lambda A is written as, so you can say wavelength of light in air. Okay, these are the meanings of symbols. So it is given that wavelength of the light in air is this. I have told you na, wavelength will change during refraction.
Yes.
Frequency will remain same. Okay. So see how you will solve this question. It is given that wavelength of light in air is 4800 angstrom. 1 angstrom is equal to 10 to the power minus 10 meter. That is a different thing. So here refractive index of diamond is given. They are asking find the wavelength of light in diamond. If you have a light, suppose, and that light, you are passing that light, and that light is passing from diamond. So they are saying in air we have this much of wavelength. What will be the wavelength in diamond? Diamond refractive index is given. So what you will do? Suppose this is the air, and this is the diamond medium. So light is traveling like this.
Yes.
Which medium is there rarer? Which medium is denser? Do you know? Diamond is denser medium. Okay. So this diagram is just for your understanding. There is no requirement of it. You can do it like.
Okay.
So here is the air, and here is the diamond. So here will be some wavelength of light, that is lambda A. Here will be the wavelength of the light, lambda D. It is given that refractive index of diamond is 2.4. So refractive index of diamond is 2.4, means always if only refractive index, like it is given that refractive index of diamond is 2.4, that refractive index will always with respect to air. Means refractive index of diamond with respect to air is equal to 2.4. Are you getting it? What I am saying? For example, it is given that refractive index of water is equal to 5. So it automatically means that this refractive index is of water, but with respect to air. Always the absolute refractive index is with respect to air. By the way, so this is given. Now we know that how to write this value. We can write refractive index of diamond divided by refractive index of air is equal to 2.4. Now there is a relation between the refractive index of medium 2 with respect to the medium 1 is equal to the V1 by V2 is equal to the lambda 1 by lambda 2. So can you use this relation to solve this question? Refractive index of diamond is given.
Yeah.
This is the so refractive index of diamond divided by refractive index of air can be written as wavelength of air divided by the wavelength of diamond from this formula. Okay, are you getting it? Means so it will be given as 2.4. So now wavelength of air is given. Wavelength of light in air is given 400 angstrom. So wavelength of light in diamond we have to find. We can find it easily. Wavelength of light in diamond is equal to 4800 divided by 2.4. So can you solve it? When you will remove point, it will become 48000,
Yes.
and here will be 24. So when you will cancel it out, it will become 2000 angstrom. Now you can see wavelength is decreasing when moving from rarer to denser medium. rarer to denser medium. This is just an example. It can be like that also. The light is traveling from diamond to air. You can consider that case also. That will be also true here. Okay, so just note down these numericals.
That's
Done. Okay. So Shafaruddin, what you will do now when you will go to your home means when after the class, just please revise your notes properly. Okay.
that's
There may be the confusion in it. The refractive index frequency is not changing and all that. So when you will study this properly, surely your doubts will be clear. And here, if you want to ask any doubt, then you are free to ask anytime in the class.
Okay.
Okay. So we have discussed the laws of reflection. Reflection. We have discussed. So laws of reflection. There are two laws of reflection. During the reflection, the incident angle is equal to the reflected angle.
yeah.
Means angle of incidence is equal to the angle of reflection. Second law is second on first. It does not matter. You can say first to second, second to first. No problem. There are two laws basically. First or second. This is not like that first law of thermodynamics, second law of thermodynamics, third law. There are two laws. Secondly, we can say whole phenomena of light is taking place in a plane, means the incident ray, reflected ray, normal at the point of incidence are lying on a same plane. Now we will discuss the laws of refraction. Laws of refraction.
Yeah.
So laws of refraction. Suppose this is the here the refraction is taking place.
Yeah.
And this is the interface and this is the medium 1, suppose medium 1, and this is the medium 2, suppose medium 2, suppose this medium has the refractive index mu1 and this medium has the refractive index mu2, and light is traveling from this medium to this medium. Okay, so this is the normal and the angle made by the incident ray, this is the incident ray. And what is this? This is the refracted ray.
Sir.
Hmm?
Yeah, you're lagging, sir.
Lagging.
Yes.
Hmm. Now it's fine. Ziyad, now it's fine. Hello.
Sir, can you hear me? Hello.
Yeah, I can hear you.
Yeah,
So
it's
now
fine.
my voice is okay.
Yes.
So this is the incident ray. This is the refracted ray. So laws of reflection, you can say first is the incident ray, normal, normal, and in refracted ray lies in the same plane, lies in the same plane at the point of incidence. This is the first law, same as that of law of reflection.
Yes.
Second law is given by the Snell's law. This is known as the Snell's law. Second law is known as the Snell's law. So second law is little bit special. So second law, there is a relation with second law tells that there is a relation between the angle of incidence and the angle of reflection,
Yes.
refraction. Okay. So wait a minute. Hmm. Hmm. Ziyad, now it's clear. His voice is okay.
Yes, sir.
Okay. Second law of refraction is Snell's law. So second law basically tells there is a relation between the angle of incidence and there's a relation between angle of incidence and the angle of refraction
Yeah.
for a given pair of medium, for a given pair of medium. Means if you are not changing the medium, then this relation will be valid. So what is that relation? Okay, totally I will explain. Suppose this is the medium 1, this is the medium 2, and uh, this have the refractive index mu1, refractive index mu2. First time, this is the incident ray and this is the normal. The angle of incidence first time is I1. Suppose just light is striking, light is going from one medium to another. First time, the angle of incidence is I1, the angle of refraction is R1. Clear?
Sir, can you repeat again?
I'm saying
Yeah.
here this light is going from one medium to another medium, you can see.
Yes. Yes.
So for the first time, uh, the angle of incidence is I1 and
Yeah.
angle of refraction is R1. Okay, this is the
Yeah.
first condition.
Okay.
Another time, in the same medium, the light is traveling.
Yeah.
Means again the light is going from medium 1 to medium 2 here. Medium 1 to medium 1 to medium 2.
Yes.
Okay, this is a medium 1 to medium 2. So we can write here mu1 to mu2 light is going. Mu1 to mu2 light is going. Here also the light is going from mu1 to mu2. After second time, the angle of incidence is I2 and angle of refraction is R2. Third time, the angle of incidence is I3, angle of refraction is R3. Again, the light is going from medium to one medium to another medium,
Yeah.
mu1 to mu2. So here what is same? Medium is same, but the angle of incidence is different.
Yeah.
So what the Snell's law says that we will discuss later. Okay, you can do this for n number of incidents
Okay.
for the light.
Hmm.
So when you will just calculate for this incidence, if you will calculate sine of angle of I1 divided by sine of angle of I2, this will be equal to sine of incidence sine of angle of incidence of I2 divided by sine of angle of refraction R2. This is also equal to sine of angle of I3 sine of R3, and this will be always remain constant.
Okay.
This is the just explanation given by Snell's law. So what the Snell's law is, now you can see. Snell's law is and. Snell's law is this. This is the Snell's law. For a given sine of angle of incidence divided by sine of angle of refraction is constant for a given pair of media. What is the meaning of given pair of media? If the light is traveling
given pair
from
of
air to
medium.
water,
Yeah.
two medium should not change. Two medium should not change.
Okay.
Okay?
Okay.
Then this law will be valid.
Okay.
But there is a special thing about this law. For a given pair of medium, for a given pair of media, basically media is plural of medium.
Medium. Yeah.
For a given pair of media, sine of I divided by sine of R is equal to refractive index of medium 2 with respect to refractive index of medium 1. And we know that refractive index of medium 2 can divided refractive index of medium 2 with respect to medium 1 can be represented by mu 2 by mu 1. Very, very important. Very, very important. This relation. This relation.
Okay.
What is Snell's law? This is Snell's law. Okay.
Okay.
So remember this. Now, how you will apply the Snell's law in the in solving the question? Suppose, for example, if you have this question, means here you want to apply the Snell's law, then how you will apply? First, you will just actually what you can do from here, you can just multiply this mu1 with sin I. Okay, you can write
Yeah.
this law as mu1 into sin I
Yes.
I1 is equal to mu2 into sine of I2. So this form of Snell's law we will apply for solving the numerical. So here see how you will apply. First you will write the refractive index of medium 1 and sine of that angle with normal. Sine of angle with normal. So this is mu1, sine of angle with normal is sine I1.
Yeah.
Is equal to mu2 into sine of angle with normal, that is sine of R2. So you can write mu1 into sine. Okay. So this is the case when the light is going from this one medium to another medium. Light can go like this also. Suppose this is the condition and here you want to apply the Snell's law. So light is going from medium 2 to medium 1. Like this the light is going. This is the angle of incidence and this is the angle of refraction. So here how you will apply? First take the medium, any medium, first take the medium from where the light is going. So here, from here the light is going. Okay, so what you will do? First write the refractive index of that medium. So this is mu2 and multiplied with sine of angle with normal. So what is sine of angle? Sine of I here is equal to write mu2 and sine of R. So in this way you will apply the Snell's law in solving the numerical. Okay, for example, we will solve one numerical. This is the numerical. This is the question we want to find.
Yeah.
We will solve. Here the light is traveling from air to some different medium having the refractive index of this. They are
Yeah.
asking find the angle of refraction. This R we have to find, and the angle of deviation we want to find. So what is the way to apply the Snell's law? What is the Snell's law? The sine of angle of incidence is equal to the divided by sine of angle of refraction for a given pair of media is constant. But here we will apply to solve this numerical uh, this mu, okay, refractive index. See, from where the light is coming, from air the light is coming. First write the
Yeah.
refractive index of air. Refractive index of air is 1, and write sine of angle with normal for that medium. So here is sine 60.
Yeah.
After that, write the refractive index of a medium in which the light is going. So in this medium, the light is going. What is the refractive index? √3. And write sine of angle with normal, that is sine R.
Yeah.
So sine 60 is √3 by 2. And here is √3 into sine R. √3 and √3 will be cancelled out. Sine R is equal to 1 by 2. So R must be 30 degree. Okay, so this angle R will be 30 degree. This angle will be 30 degree. Now what is the angle of deviation? Angle of deviation means how much the light is deviated. By how much angle the light is deviated. If there is no refraction, the light will go straight like this.
Yeah.
Okay, obviously the light will go straight like this. So angle of deviation is basically this angle. This angle.
Yeah.
Angle of deviation, del. Angle of deviation is represented by del. And this is angle of refraction R. So this angle, can you find this angle? If this angle is 60 degree,
Yeah.
then this whole angle will also be 60 degree.
Yes.
This whole angle will also be vertically opposite angle. So
Yeah.
this whole angle will also be 60 degree. So if this whole angle is 60 degree and this angle is 30 degree, so this angle will be also 30 degree.
Yeah.
Okay. So del you can find 60 minus 30, that is equal to 30 degree. That is the angle of deviation. Another question. Okay, first I think you should note down now. Okay, take the screenshots.
Done, sir.
Hmm.
Done, sir. Done, sir.
Just a minute. Here the light is going from. Take this screenshot again.
Okay.
Here to here.
Will take, sir. Done, sir.
Okay. Take this.
Done, sir.
Okay.
Done.
So this is the next question. Okay, so try this question by yourself. Okay.
Okay.
and in the next class I will discuss this question. Here what you have to do na, here you have to apply the Snell's law.
Yeah.
And Snell's law is valid for a given pair of media. First what you will do, apply the Snell's law in medium 1 and medium 2 for this pair of medium, and after that you will apply the Snell's law for this pair of media or medium. Then you will get this angle E. Okay, Ziyad. So please remember all these things. What is the meaning of remember? Means revise these things. Okay.
Okay.
So in a proper manner means revise properly. If you have any doubt in the, so in the next class, when you come to the next class,